All right, the next thing we are going to do is actually a little mini project. So in this project, we are going to find some real world data that is approximately sinusoidal, okay, and fit a sine curve to it. So we're going to use Desmos to do that, and a process that we have laid out to find our A, B, C, and D values. So the first thing is to find some periodic data. Okay, so on the first sheet in this document, I have a few websites listed, but you can Google anything that you want. Okay, so common types of periodic data are, average daily temperatures, hours of daylight, tide levels. Okay, those things, if you look at them over the course of a year, will be cyclical. Okay, they'll go up and down and up and down. So I'm going to go through an example of this process where I look at an average daily temperature. Okay, so I will award bonus points if you use periodic data that is not one of these three things. Okay, that is not temperatures, that's not hours of daylight, that's not tide levels. Okay, if you find something creative or even take your own data somehow, okay, I will award up to 5 bonus points. Okay, and make sure that your data is periodic. Right, if you have a question about it, just ask me. Okay, so for my data set, I just Googled daily average or monthly average temperatures for Canton, Ohio. Okay, so I'm going to choose to look at the high temperatures by month. Right, so the first month, 33 degrees, second month, 37 degrees, and so on. So the first thing we want to do is just create a table in Desmos. Okay, so if we pull up Desmos, right, and we put or click on this plus, one of the options is a table. Okay, so we can start putting in our data. So the first data point, the average daily high in January was 33, right? Yeah. Then second, which would be 37, and so on. Okay, now one thing that we want to make sure is that our graph is to scale. So I'm going to be going up to the 12th month on the x-axis, and I'm going to be going all the way up to a high of 83. So to change the scale, click on the wrench up here, and then we can type in whatever min and max we want for both axes. So the y-axis, we said, well, just so we can see the x-axis, I'll go -5 and then say 100. Then on the x-axis, if we want 1 to 12, I'm going to say -1 to 13, just so we have a little buffer room. Okay, so here, right, we start to see that data. Okay, so if we type all of that in, we'll see this. Okay, once I type all that data into the table, okay, here's what that curve would look like. All right, so the first couple of things I want you to do are to take a screenshot of your table and then take a screenshot of your graph. Okay, once you have that typed into Desmos. So that will go here and here. So then next is to actually calculate the A, B, C, and D values and put those into an equation. So the amplitude, our A value, to find that, we're going to find our largest Y value and our smallest Y value. Subtract them and then cut that in half. That'll get me the distance from the midline to the max and the min. So if I go back to my data here, well, it looks like the smallest high is 33 and the largest high is 83. So I'm going to subtract those. So 83 minus 33 and divide that by 2. So that's 50 divided by 2 is 25. So my A value is going to be 25. Next, to find the D value, we want to see how much the midline is shifted. Right? So to find the midline, we just want to find the average of the highest and lowest Y values. So we just said that those highest and lowest values were 83 and 33. So to find average, I add them together and divide by 2. So 83 and 33 would be 116, over 2 would be 58. So my midline is 58, okay? And if we go back to our graph, right, just to start to get a little bit of info here, we can type in that midline, y equals 58. And if we want to make it look dashed, we can click and hold here, and then we get some options. We can change the color, we can change the thickness, but I just want to make it a dashed line, right? And I'll make it a different color too. Okay, so clicking and holding here lets you change a lot of options, right? So if we go back, the next thing that we want to figure out is our horizontal shift. And another word that you might hear for that is the phase shift. So there are a couple of ways to do this. Okay? First is to find the distance from the y-axis to the first point that touches the midline. Okay? So we just put our midline on there. So what we want to think about is, well, normally sine would start on the y-axis, right? So we want to see, well, how far is that shifted over? So where would we be starting here? Well, it looks like, a little bit less than 4 is where, if we, drew a line in here, that's where that would cross, right? So maybe at like, I don't know, 3.75 or something like that. Okay, so this we want to do visually. We want to use the graph, right? We're not using a mathematical process, right? We're just looking at the graph and saying, well, if I sketched this curve, it would cross at, I'm going to approximate 3.75 here, okay? And we'll be able to adjust this later if we need to. Then finally, our b value is related to the period. So this is the distance from this first place your set of points crosses the midline until one full period has been completed. That method you can use if you have more than one period worth of data. I actually only have one period worth of data, right? This data set occurs over 12 months. So we know that one full period is equal to a distance of 12, right? So to solve for b, right, we said that the period is 2 pi over b. Well, in this case, I know that my period is 12 months. And this is going to be true for a lot of data sets, right? A lot of things are periodic over 12 months, right? Average temperatures, amount of daylight, those types of things, right? So to solve for b, well, if I multiply both sides by b, I'd have 2 pi equals 12b. Divide both sides by 12, and we'll have 2 pi over 12 equals b, or that would reduce to pi over 6. So that would be my b value here, pi over 6. So we want to take all 4 of those pieces of information now and put them into an equation. Right? So we said the a value was 25. So 25 times the sine of b was pi over 6 times c, we said was like 3.75. And then d, we said was 58. So here is the first version of my equation to model this data. Right? So if I type that into Desmos, this is what that would look like. And it looks pretty close, but it actually does look a little bit off. Right? So the next part, you would take a screenshot at this point, right, of your curve that you have created, put it into your document. But then the next part is to make any necessary adjustments, right? That process that we just went through gets us a good approximation, but it's not perfect, right? So now we can use what we know to adjust the graph. So I would say it looks like this needs to go to the right a little bit. Well, that would be this value here, right? My C value. If I increase that, that will make the graph go to the right. So let's bump that all the way up to 4, right? That looks a little bit better. It maybe even could go a little bit more to the right. How about 4.1? See, that looks pretty good. It actually might be able to go up a little bit as well to fit this data. So let's say we add 59, right? That actually looks pretty good. Okay, that looks, if I take all of my data into account, that looks about as close as I could get to all of these points. Okay, so In this step, just play around with all the different values. We could have changed the a value a little bit, right? We may even want to do that. Make that 26 or 24, right? Just play around with all the different values to see what's going to give you the best fit, right? So if you go through that process, you're going to get your graph really close, and then use a little bit of common sense and guess and check to get your graph as close as possible. And once you do, to write down or type in or take a screenshot of your final equation along with your final graph. Okay, so you'll have at this step, right, you'll have the picture of your graph as is as soon as you finish that 4-step process, but then make some adjustments if you need to and take a screenshot of your new graph. Okay, then the next part is to give domain, range, amplitude, and period. Okay, I'm going to let you guys figure that out and figure out how to interpret that in terms of your data, right? So you're not just giving me the domain and range, you're giving me the domain and range and also explaining what that means in the context of your data, right? Same with the amplitude and the period. And then finally, the last page is just how you're going to be awarded points, okay? 5 points as long as your data actually fits a sinusoidal pattern. 3 points each for correctly calculating your A, B, C, and D. Neatness, right, and correctly modeling the data is 5 points. Domain, range, amplitude, and period are correct and explained in context. Then presentation of the product is 5 points. And then, like I mentioned, you could get up to 5 bonus points for your creativity of data choice, right? So you could get 30 out of 30 if you choose one of those 3 types of data I outlined in the beginning, but you could get up to 35 out of 30 if you give me some creative data. All right, so we'll work on this for a couple of days in class.